Assalamualaikum dan salam sejahtera. We still focus on chapter 7, ionic equilibria, but now we are going to look at the subtopic 7.2, acid-base titration. So let's start. Okay, what is acid-base titration? Before this, you already carry on the experiment in the lab. Okay, so this is the definition of acid-base titration, which is a solution of accurately known concentration. This is we call as standard solution. Is added gradually to another solution of unknown concentration until the chemical reaction between the two solutions is complete. So this process, acid-base titration, this process we call as neutralization process. Okay, boleh? So what is titration process? Titration is a method for determining the concentration of a solution using another solution, which is we know the concentration, called as standard solution. So this is the process of titration yang you dah biasa buat dalam kelas amali. Okay, so in the burette here, for example, normally the burette you fill in with sodium hydroxide. Okay, so the solution that we fill in the burette we call as titrant. And then we have the solution in the conical flask. Normally we fill in with HCl atau acid. Kadang-kadang boleh juga berubah ya kelas. Okay, the solution that we place in the conical flask we call as analyte. Okay, and then we know that during the titration we need indicator for to know the end point, right? Okay, so normal indicator that you use is phenolphthalein. Okay, so please remember here class, conical flask, analyte, in the burette we call as titrant. Okay, you kena tahu benda ni dulu before you solve the question that involve titration curve. Okay, perkara yang melibatkan titration curve you kena tahu. Kadang-kadang dalam conical flask pun boleh diisi dengan base, dalam burette pun boleh diisi dengan acid. So tak semestinya burette diisi dengan base. Okay, so bergantung kepada soalan. Okay, so next we look at the difference between endpoint and equivalent point. So what is endpoint? Okay, so this is the answer. Endpoint, the point at which the indicator change color. For example, masa you buat dalam lab, you guna phenolphthalein. So phenolphthalein, when you get the pale pink color, so you know that that's your endpoint. So you need to stop your titration. Okay, so please choose the indicator with an endpoint close to equivalent point. So normally endpoint dengan equivalent point adalah pada masa yang sama, but the definition is different. Okay, so equivalent point means the point at which the reaction is complete. Means when acid react with base, so kalau you dah dapat pale pink tadi tu, so bermaksud you dah achieve, you dah dapatkan salt and water sahaja pada conical flask. No more acid left. Nampak no more acid or base left in the solution. Okay, so dalam conical flask awak cuma ada salt and water. Okay, and equivalent point juga equimolar amount of acid and base have reacted. So this one we need to identify it from the stoichiometry. Okay, so biasanya kalau dia punya ratio acid dengan base 1:1, so number of mole at equivalent point adalah sama. Kalau 1 to 1 lah. Tapi kalau ratio dia 1 kepada 1 kepada 2, 1 kepada 3, so dia punya number of mole acid and base akan a little bit berbeza. But you need to know, at equivalent point, no more acid, no more base left. Okay, so please remember this one, sebab you akan guna nanti dalam calculation part. Okay, next we look at pH range. Okay, so pH range, you need to know this one. Why? Okay, so acid base titration ada beberapa jenis. Okay, kejap lagi kita akan tahu. So indicator juga ada beberapa jenis. So make sure you choose the indicator, the range over which the indicator change. You kena tahu jenis tindak balas yang berlaku. Okay, from the acid color to the base color. Okay, so for example, normally indicator that we use here is phenolphthalein. So the pH range for phenolphthalein is 8.3 to 10. Okay, and then we have methyl orange. So the range is 3.1 to 4.4. And then we have methyl red. Okay, the range is 4.2 to 6.3. Okay, for methyl orange and methyl red, kita tak pernah guna in our titration process except for the student SES. Pelajar senior pernah guna methyl red atau methyl orange lah masa zaman you all SES dulu kan. Okay, tapi untuk pelajar junior you all memang tak pernah guna lah sebab you biasa familiar dengan phenolphthalein. Okay, so macam mana nak tahu benda ni kan, yang mana yang suitable for our titration process? Alright, so the pH range at equivalent point is determined from the steep vertical portion in the titration curve. Okay, what is steep vertical portion? So after this, later I will explain to you. Okay, based on the titration curve. Okay, the important thing here, what you need to know is this one. Okay, the pH jump. So actually class, we have 3 type of titration. Okay, we have strong acid react with strong base, strong acid react with big base, weak acid react with strong base. So you need to know the pH jump. So pH jump ni you kena tahu untuk you sketch the titration curve. Okay, I'll show you. If you use strong acid and strong base, the pH jump between 3 to 11. Nampak between 3 to 11. So untuk strong acid and strong base, sebenarnya you boleh guna mana-mana indicator sebab this range include in this pH jump. Tapi the normal indicator that we use is phenolphthalein. So this one range include tak dalam ni? Boleh masuk. So boleh terima. So kalau if you use strong acid and weak base titration, the pH jump 3 to 7. So the suitable indicator that you need to use either methyl orange or methyl red only. You cannot use phenolphthalein. Okay, dia tak sesuai. And then if weak acid and strong base, the pH jump 7 to 11. Okay, so this one is depends on the equivalent point here, class. Okay, so 7 to 11. So 7 to 11, so the suitable indicator that we can use here is, yes, you can use phenolphthalein. Nampak? Okay, you tak boleh guna methyl orange dengan methyl red. Sebab dia tak boleh detect dia punya endpoint dengan equivalent point dia nanti. Okay, so later I will discuss more after this. Okay, so this is the type of titration we have. The first one, tadi saya dah bagi tahu dah. Okay, the first one we have the reaction between strong acid and strong base, and then we have weak acid and strong base, strong acid and weak base. So we are going to look at one by one of this type of titration after this. Okay, I will explain to you first before we look at the calculation and how to sketch the titration curve. Okay, we look at the first type of titration, which is strong acid react with strong base. Okay, look at this statement first. Titration of 40 ml of 0.1 molar HCl with 0.1 molar sodium hydroxide. Okay, so this is the titration curve. Later, we are going to learn how to sketch the titration curve. Okay, I want you to look at this statement first. So from this statement, you need to know which one is your analyte, which one is your titrant. Jangan kata oh HCl acid mesti duduk dalam conical flask, base mesti duduk dalam burette. No class, tolong jangan predict macam tu. Okay, itu yang biasa you all buat dalam kelas amali, tetapi dalam soalan dia boleh berubah. So be careful class. Okay, be careful. So dekat sini macam mana clue nak tentukan dia? So tengok apa yang diberi dalam soalan. Yang pertama dia bagi volume dan concentration HCl, and then you ada concentration sodium hydroxide. So this is the biggest clue class. So bila dia beri volume, okay, bila dia beri volume awal bagi sesuatu substance atau compound, itu adalah awak punya analyte. Biasanya analyte kita tahu berapa volume dia sebab kita pipette. Betul tak kelas? Kalau awak ingat lagi, kita akan pipette 25 ml acid you place in the conical flask, right? So we know the volume, we know the volume of the substance in the conical flask, which is the analyte. But the volume of titrant normally kita tak tahu selagi you tak buat titration. Am I right? Nampak? So from this keyword, we know that our analyte should be HCl, while our titrant in the burette should be sodium hydroxide. So tolong predict benda ni dulu. Nanti dalam calculation, and if you want to sketch the titration curve, you need to know this one first. Kadang-kadang soalan dia terbalik ya. Kadang-kadang sodium hydroxide dalam conical flask, HCl dalam burette. Boleh ya? Jangan kata tak boleh. Okay, so next, this is the titration curve. Macam mana dia diplot? Okay, ni yang saya nak explain dulu. Later, kita akan belajar how to sketch. Okay, so kita tengok explanation dia. Okay, untuk strong acid dengan strong base, for this case, kita punya analyte HCl and sodium hydroxide adalah titrant. Okay, so the pH, okay, look at the first explanation. The pH start out low. Why the pH start out low? Because our analyte is strong acid. Okay, our analyte is strong acid. So strong acid consists of higher concentration of H3O+. So that's why if we look at the first point here, we start the pH sangat rendah. Sebab analyte kita belum tambah base ya. Ini sebelum you add base. Okay, so this is the pH in the conical flask now before adding strong base. Faham? Okay, next, the pH gradually increase. Why increase? Because we start added sodium hydroxide drop by drop. Nampak So bila you start added strong base sodium hydroxide, dia akan meningkat sikit demi sikit. Sebab pH dia akan bertambah lah. Concentration H3O+ akan berkurang dan concentration OH- mula bertambah sedikit demi sedikit. Boleh nampak? Suddenly the pH rise steeply. Ini yang saya nak bagi tahu ni. Inilah steep portion. Okay, yang saya mention tadi dalam slide before this. So this is the steep portion. Okay, yang menunjukkan dia adalah dekat sinilah yang awak kena hafal tu, pH jump. Okay, so pH jump for strong acid and strong base is 3 to 11. Lebih kurang lah ni 3 ke 11. Nampak tak? So kawasan situ you kena lukis vertically, tegak. Okay, tegak. Okay, so dia macam curve ni macam bentuk Z ala-ala kan. Okay, tapi kat situ tegak. Itu yang dipanggil sebagai steep portion. So the pH will rise steeply. Nampak? Okay, and then at pH equal to 7, see, at pH equal to 7, this is the equivalent point, means the mole of OH minus added equal to the mole of H3O plus. Okay, so this is your equivalent point. So kita tahu when strong acid HCl react with sodium hydroxide, it will produce NaCl plus H2O. So at equivalent point, you akan ada cuma NaCl and H2O. Nampak? So at equivalent point, no more acid left, no more base left, only salt and water. So the salt here, so the pH of equivalent point depends on the salt produced. I repeat, the pH at equivalent point depends on the salt produced. So the salt produced here is sodium chloride. So sodium chloride, if you still remember in chapter 7.1, saya ada mention, kita ada belajar kelas. So reaction of strong acid and strong base will produce what type of salt? Yes, will produce neutral salt. What is the explanation? Refer balik 7.1. So neutral salt, the pH should be equal to 7. That's why our equivalent point here is 7. Okay, and then if you still continue adding sodium hydroxide after equivalent point, kalau ikutkan you dah dapat pale pink lah kalau you guna phenolphthalein. Okay, tapi katakanlah you nak still adding juga sodium hydroxide, so you akan dapat ribena lah nanti. Tapi tak apa, teruskan. Okay, so after equivalent point, okay, kalau you still adding sodium hydroxide, so dia akan awak nampak pH jump from 6 to 8. Okay, kenapa? Sebab pada lepas equivalent point, selepas equivalent point, no more acid left. Sebab dekat equivalent point pun dah tak ada acid. So but if you still adding sodium hydroxide, bermaksud akan wujudnya sodium hydroxide dalam conical flask bersama dengan salt and water. But acid dah tak ada lah. Sebab equivalent point dah habis. Pada equivalent point acid dah habis. Boleh nampak? Okay, and pH will increase slowly again. Why? Because of the addition of sodium hydroxide. Okay, while it will increase slowly sebab ada wujudnya sodium hydroxide in the conical flask. So the pH in the conical flask now must depends on the sodium hydroxide solution. I repeat, the pH after equivalent point must depends with pH of sodium hydroxide. No more acid left, right? Okay, next we look at the titration of a weak acid with a strong base. Okay, weak acid with a strong base. So, what type of weak acid we have here? So, kita ada propanoic acid here, HBr. Okay, ini adalah propanoic acid react with sodium hydroxide. Okay, please predict which one is our analyte, which one is our titrant. Okay, so look at the tips, look at the clue. Apa tips yang diberi kat sana ni? Bukan tips lah, clue lah sebenarnya kan. Okay, apa clue yang diberi? Yes, you have the volume of propanoic acid. So it means that in your conical flask should be propanoic acid, while in your burette should fill in with sodium hydroxide. So sekarang dah tahulah. Okay, so that's why your titration curve start dekat bawah. Bermula daripada pH yang bawah. Nampak? Okay. So the initial pH is higher, a little bit higher compared to the first titration tadi. Before this. Okay. Sebab before this kita guna strong acid. Okay. Now we use weak acid. So dia a little bit higher compared to the strong acid. Kalau strong acid tadi lebih kurang kat bawah ni kan. So ni dia tinggi sikit lah. But it's still less than 7 lah. Okay. And then a gradually rising portion of the curve appear before the steep rise to the equivalent point called as buffer region. Okay. So and then ini sebelum adding sodium hydroxide. So pH awak bermula dengan 3 macam tu. Okay. And then when you start adding sodium hydroxide, okay, when you start adding sodium hydroxide, okay, saya nak kena buat equation dulu. Nak bagi awak nampak kan. Okay, propanoic acid. Contoh kalau awak buat HPr react with NaOH, so you akan dapat okay, PrNa plus H2O. Okay, PR ni sebenarnya panjang ni sebenarnya. Dia macam ni, CH3 CH2 COOH. Ni propanoic acid sebenarnya kelas. Okay, so yang ini kalau kita tulis betul-betul dia adalah CH3 CH2 COONA. So this is the correct one. So you akan dapat, okay, bila you start adding base in the conical flask, okay, so apa orang kata, salt and water akan terhasil. Betul? Saya ulang. Bila you add sodium hydroxide in the conical flask, so salt and water akan terhasil. Okay, katalah you letak 2-3 drop pun salt akan terhasil. So bila terhasilnya salt dekat sini, cuba awak tengok, ini weak acid class. So weak acid, okay, bertemu dengan salt dia, di mana dalam salt ni ada CH3 CH2 COO minus, which is refer to the conjugate base of the weak acid. So bila weak acid bertemu dengan conjugate base dia, ini menunjukkan wujudnya buffer solution. Still remember buffer solution in chapter 7.1? Okay, so ini refer kepada buffer solution. Nampak? So sebab tu before equivalent point ada wujudnya buffer region here. Nampak? Because in this part consists of weak acid and its salt, which is containing the conjugate base of the weak acid. So you kena kenal pasti sebab apabila melibatkan weak acid dengan strong base. Okay, and then if you still continue added sodium hydroxide, and then you will achieve equivalent point here. Nampak equivalent point dia 8.8 pH dia. Kenapa bukan 7? Kelas, kenapa bukan 7? Kalau tadi 7. Saya ulang lagi sekali, the pH, okay, the pH at equivalent point here, okay, must depends on the pH of salt produced. I repeat, the pH of equivalent point must depends on the pH of salt produced. So this is our salt. Ni salt kita tadi. So if you still remember in chapter 7.1, if weak acid react with strong base, it will produce basic salt. Okay, di mana pH should more than 7. So look, our pH here is 8.8. So betul lah. So this is basic salt. So make sure pH at equivalent point bergantung kepada salt. Nanti bila awak belajar pengiraan, you tak perlu kira sebenarnya kelas pH at equivalent point ni. So you just letak more than 7 saja. Yang ini memang dia dah buat eksperimen yang sebenar. Okay, but if you still continue adding base, okay, so ingat at equivalent point hanya tinggal salt and water sahaja. No more acid left, no more base left. But if you still continue adding base, the pH akan meningkat lagi lah. Nampak pH akan meningkat sebab lepas equivalent point akan ada sodium hydroxide sahaja. Okay, saya ulang. Selepas equivalent point akan ada sodium hydroxide sahaja. Sodium hydroxide dengan salt sahaja. Okay, no more acid left. Okay, after equivalent point. So after equivalent point, the pH should depends on sodium hydroxide. Saya ulang. After equivalent point, the pH should depends on sodium hydroxide, which is our strong base. Okay, tengok dia punya steep portion here class. pH jump. Ini weak acid dengan weak base. So kalau weak acid dengan weak base, pH jump suppose berapa? 7 to 11. Ini pH jump. Cuba tengok kita punya steep portion here. So dia dilukis lebih kurang antara 7 ke 11. Okay, so the indicator that's suitable here is phenolphthalein. Saya dah cakap tadi. Okay, kalau weak acid dengan strong base sesuai pakai phenolphthalein. Kalau yang strong acid dengan strong base tadi, awak boleh lihat semula tadi dia bagi dua pilihan. Either boleh guna minta red or minta orange ataupun phenolphthalein. Okay. Okay, next, the last type of titration we have here, titration of strong acid with a weak base. Kenapa gambar kali ni bukan pale pink kan, gambar titration, nampak? Okay, gambar titration kita bukan pale pink lagi. Ni dah jadi metal red. Kenapa ni? Tadi kan dah tahu dah dia punya pH range. Okay, so let's look at this statement first. Okay, titration of 40 ml of 0.1 molar ammonia. See, ammonia is the weak base. Okay, kalau dalam soalan normally dia akan bagi nilai Kb. Okay, kalau macam soalan sebelum ni, yang titration sebelum ni weak acid dengan strong base, so normally dia akan bagi nilai Ka untuk weak acid. So dekat situ you all boleh kenal itu adalah weak acid atau weak base. So jangan risau kalau dalam soalan lah. Okay, so ini cuma yang saya nak explain je. So ammonia adalah weak base, react with 0.1 molar HCl. Now I want to ask you, so which one should be our analyte? Yang mana akan jadi analyte? Adakah acid? No. So look at the volume here. The volume given for ammonia class. So yes, in the conical flask should be replaced with NH3, while in the burette kita akan fill in with HCl sebab the volume here class. Kita dah ada volume awal. So volume awal tu biasanya mesti berada dalam conical flask. That's the clue class. Please remember. Okay, so now that's why look at your titration curve now. So apa yang you boleh lihat pada titration curve ni? So we start our curve daripada atas turun ke bawah kelas. Kalau tadi yang dua tadi semua start daripada bawah naik ke atas. Kenapa yang ni start daripada atas? Yes, because the pH start with weak base. Okay, because our conical flask contain weak base. So the initial pH here before we start the titration adalah initial pH from weak base. So that's why the pH should more than 7 sebab base kan. Okay, nampak? Alright. So when you start adding HCl, okay, the pH will decrease gradually. in the buffer region. Kenapa pula wujud buffer region kat sini? So let me explain to you. Okay, kenapa ada buffer region kat sini? Okay class, kalau HCl react with NH3, okay, it will produce NH4Cl. So this is the salt. Okay, ini adalah salt. Okay, nampak So sebelum equivalent point, before equivalent point, okay, it must consist of nampak it must consist of NH3 and its conjugate acid. So class, sebenarnya dalam salt ni ada NH4+. So NH4+ ni adalah conjugate acid of weak base. So ini weak base NH3. So NH4+ ni adalah conjugate acid. So bila NH4+ bertemu dengan NH3, wujud apa kelas? Yes, weak base bertemu dengan salt dia, di mana dalam salt tu ada conjugate acid of weak base. So this is buffer solution. So that's why before equivalent point, the buffer solution muncul dekat situ kelas. Tolong label kawasan buffer region ni. Okay, nanti dalam titration curve awak, strong acid dengan strong base tidak ada buffer region kelas. Buffer region terjadi jika ada weak acid dengan weak base. Nampak? Okay, kemudian the curve drop vertically to the equivalent point. So kita tengok kat sini equivalent point kita. Berapa equivalent pH dia? 5.27 kelas. Kenapa pula 5.27? So remember, at equivalent point, apa yang berlaku kelas? At equivalent point, no more acid left, no more base left. Only salt sahaja yang tinggal. So salt kita adalah NH4Cl. Kalau awak masih ingat, NH4Cl adalah acidic salt. Okay, so acidic salt, the pH should less than 7. Nampak? So sebab tu pH yang kita ada kat sini kurang daripada 7. Kemudian look at the pH jump, steep portion here. Okay, pH jump for weak base react with strong acid. pH jump dia antara berapa kelas? Antara 3 kepada 7. Okay, 3 kepada 7. So indikator yang sesuai kita guna either methyl red or methyl orange. Sebab tu kalau awak tengok pH jump kat situ antara 3 kepada 7. Nampak tak dia punya steep portion? Okay, so steep portion dia antara 3 kepada 7. Boleh nampak? Okay, so and then after equivalent point, kalau you still add, nampak methyl red warna dia bukan pale pink, warna dia merah lah. Okay, warna untuk methyl red adalah merah. Nampak Okay, so if you still added sodium hydroxide, salah, bukan sodium hydroxide, HCl. Okay, titrant kita HCl class. So after equivalent point, if you still added HCl, so the pH will decrease slowly. Why? Because of the H3O+ ion. Okay, come from where? Come from HCl. Sebab tu after equivalent point, base dah tak ada ammonia dah tak ada. Kenapa? Sebab dia dah complete react dengan HCl. So after equivalent point cuma ada salt NH4Cl dan juga HCl. So the pH here after equivalent point must depends on the strong acid. Kalau strong acid bertemu dengan salt, tak jadi buffer Saya ulang, strong acid bertemu dengan salt dia tak jadi buffer. Sama juga strong base bertemu dengan salt, takkan jadi buffer solution. So the pH after equivalent point here must depends on the strong acid only. So senanglah kerja awak nak kira pH. Guna formula pH equal to negative log H3O+. Okay, finish about explanation of titration curve. Later, we are going to look at the calculation and how to sketch the titration curve. Okay, so kita akan lihat dalam video yang seterusnya. That's all guys. Thank you.